Hey everybody, today is a quick look at percent composition. At this point, we should have gone over this in class, and if you need to refer back to the lecture, it's up. Please take a look at it on my site. But I wanted to go through an example for you on the 1 through 5 first, and then we'll reconvene and go through the second chunk. Don't need anybody's heads exploding, so let's just try to get through this with the percent composition. But before we even begin, let's just take a quick look at the words here, percent composition. You know, composition is what something's made up of, and this percent is of 100. In other words, we're trying to figure out of the 100% that we have of something, what's it made up of? So like if you take a peek at cent, right? You know, like a century is 100 years, or a cent is 100th of a dollar. Percent is just of 100. So we're going to kind of apply that to chemistry. And for some reason, making that jump sometimes gets confusing for kids. But here's something I want you to keep in mind. If we had a test and our test was out of 35 points possible, and I were to say, hey man, you did okay. You got a 29 out of 35. You wouldn't just say, oh, okay, is that good or is that bad? Or perhaps you would. But many of you know that if you had to figure out what the heck percent, what's my grade on a 29 out of 35 point assignment, this is 35 points total. And this is 29 correct. So basically you're taking how many correct out of how many possible. So if I reach for a calculator and I go 29 correct divided by 35 total, my calculator gives me 0.8285714. And a lot of you could look at that and say, look, I understand that I moved this over twice, or some of you are a little more thorough and say, I'll go times 100, and you'd see that you got an 82.86, we'll call it, percent on that test or quiz or whatever. In other words, you know, you scored almost a B, still showing up as a B- on the transcript. What we did there is we figured out how many correct out of how many possible. So we need to be able to do that with compounds. But here's something else that I want you to kind of think about. Let's say we had H2O. So here's our water, right? If I were to say, hey, what do we have more of in H2O? At a glance, the obvious answer is, well, we've got more hydrogen. There's two of these guys, right? You've got H, there's your subscript, 2O. So I get that there are technically more hydrogens than oxygen. But if we reach for a periodic table, things get a little bit more complex. We're not looking at how many, but if we're looking at by mass, hydrogen is 1.01. So if I've got two of these guys, by these guys I mean hydrogen, quick like a rabbit, 2 times 1.01, that should give us 2.02 grams per mole. And again, you know, if you don't remember what the grams per mole is, you can see previous lectures or videos, but basically that's saying if I could take hydrogen and I got hydrogen atoms and somehow I can put them on a balance, 1 atom, 2 atom, 3 atoms, all the way to that monstrous number of 6.02 times 10 to the 23, that balance for 1 mole of hydrogen would tell me it's 1.01 grams. Anyways, review that if you need to. So we got 2.02 grams per mole of hydrogen. And then I take a look at oxygen, and even though there's only 1 here, that oxygen is coming in at 16.00 grams per mole. So now if I said, what's there more of? 16 grams per mole of oxygen or 2.02 grams of hydrogen, then the question's kind of a little bit different. And that's kind of what we got to figure here. So if any of that's confusing, like I said, feel free to review a previous video or a lecture, or, you know, ask me, and I'll be happy to bring you up to speed. But here's what you need to be able to do with this first part of percent composition. Some of it's review, and it's kind of building on what we did before. We got to figure out what our total mass is. And if we look at our total mass, And then we got to figure out what our element's mass is. And then we can take a look at each particular element. So I'll do this first guy for you. And again, this is how I set it up. I'd say, all right, I'm looking at this, and I've got some copper, and I've got some bromine. Check. Cash, how did you know that those were only two? Because they're lowercase, right? That tells me the break of those elements. Then I figure out how much there is of each one. So I got 1 copper and 2 bromine. So now I go to my periodic table. Copper lives here, 63.55 grams per mole. And then I look, bromine lives over here, 79.90. All right, so now I got to reach for a calculator and add up what my total mass of this copper bromide is. So I'd say, all right, I know that one is 63.55. And then I take a look at this. I got to reach for a calculator, 79.9 times 2. Bromine is bringing 159.80 to the party. We add these guys up, right? They should seem kind of familiar. This is like what we had to do with the molar mass. And we're going to take one more little baby step. So I got the 159.80 bromine plus 63.55 from my copper. And that gives me a total of 223.35 grams per mole. That is the total mass of copper bromide. I'm trying to figure out, well, what percent of this is copper and what percent is bromine? Okay, so what do? We take the element's mass and we divide it by the total. So for my copper, I'd go 63.55 over 223.35. And then for my bromine, I'm going to go 159.80 because that's how much of this is bromine. So I go 159.80 over 223.35. So I got to figure out percent copper, that's supposed to be a U, and percent bromine. And here's what I'll do. Let's do the copper first. So I go 63.55 divided by 223.35. And I got that. So now technically I should hit multiplied or times 100. So just if I go times 100, it gives me 28.4531. I'm going to go to the hundredths and I'll call this 28.45% copper. 28.45% of copper bromide is copper. Now for the bromine, that much of it, of that much total, I do the exact same thing, right? 159.8 divided by 223.35 equals, I got that, times hundo equals that. And I'm going to call it 71 point, I'll call it 55. I usually go to the hundredths, and I think that'll be okay to get us through. So now if I've got 71.55% bromine, 28.45% copper, there's a way that I can check to see if I'm right, or at least good. So what do? Remember, we're figuring out percent of 100. I should be able to account for 100% of that mass here. So if I take these masses, or these percents, however you want to think of it, probably percents is better. If I go 71.55 plus 28.45, boom, all day long, 100%. So I know for sure I'm correct. Now, here's something I will say. As you're working through the rest of this practice, say you do this double check and you're like, Cash, I don't know what I'm doing wrong, man. I'm like at like 98.9 something or, 99 something. Or you got to remember, I just rounded to the hundredths and this worked out to where that's great. I got exactly 100%. If you've got like a long string of digits behind your decimal and it's not working out, then then, maybe we just rounded a little bit funky. But anyways, that's how this works out. Hope that's helpful. Try to get through the 1 through 5, and then we'll move on to this when next we meet. Toodaloo.